Hey there. Ever wondered why it's harder to push a full shopping cart than an empty one? It's a common experience, but there's a fascinating scientific principle behind it. Well, that's Newton's second law of motion at play. This law is one of the cornerstones of classical mechanics. Let's break it down in simple terms so you can understand how it affects your everyday life. Newton's second law states that the force acting on an object is directly proportional to the acceleration of that object and inversely proportional to its mass. This means that the force required to move an object depends on both how heavy the object is and how quickly you want it to move. In other words, the heavier the object, the more force you need to move it. This is why pushing a heavy object feels much harder than pushing a light one. This law is neatly summed up in the equation F equals ma, or F equals sine ma. Here, F stands for force, measured in newtons. This is the push or pull you apply to an object, stands for force, measured in newtons. Think of this as the push or pull you apply. Every time you push a door open or shove a cart, you're applying force. M is the mass of the object in kilograms. It's how heavy the object is, and it plays a crucial role in determining how much force is needed. It's how heavy the object is. The more mass an object has, the more it resists being moved. And A is the acceleration in meters per second squared. This is how quickly the object speeds up when a force is applied. Is the acceleration in meters per second squared. This is how quickly the object speeds up. The greater the acceleration, the more force is needed to achieve it. Imagine you're at the gym. If you're lifting a light dumbbell, say 2 kilograms, it's pretty easy to lift quickly. You don't need much force to get it moving. If you're lifting a light dumbbell, say 2 kilograms, it's pretty easy to lift quickly. You can lift it with minimal effort and achieve a high acceleration. But if you switch to a 20 kilogram dumbbell, you'll need a lot more force to lift it just as fast. The increased mass requires more effort to achieve the same acceleration. That's because F equals ma. More mass means you need more force for the same acceleration. More mass means you need more force for the same acceleration. This principle is evident in many aspects of our daily lives. Now let's think about a car. If you want to accelerate quickly, you need a powerful engine to generate a lot of force. This is why high-performance cars have such powerful engines. If you want to accelerate quickly, you need a powerful engine to generate a lot of force. The engine's power translates into the force needed to speed up the car. That's why sports cars, which need to accelerate fast, have engines with a lot of horsepower. The more powerful the engine, the greater the force it can produce. On the other hand, a heavy truck needs a lot of force just to get moving, even if it's not going to speed up as quickly as a car. The truck's large mass requires significant force to overcome its inertia. This law also explains why lighter objects can be thrown further than heavier ones. When you apply the same force to different objects, the lighter one accelerates more. When you throw a ball, you're applying a force to it. The lighter the ball, the more it accelerates and the farther it travels. If the ball is light, like a tennis ball, it accelerates quickly and travels a long distance. The force you apply is enough to give it a high acceleration. But if the ball is heavy, like a bowling ball, it doesn't accelerate as much and it doesn't go as far. The same force results in less acceleration due to the greater mass. So, next time you're moving your furniture around or trying to win a tug of war, remember Newton's second law. The force you apply and the mass of the objects determine how easily they move. Understanding this principle can help you appreciate why heavier objects need more force to move. It's a fundamental concept that explains so much about the physical world. It's not just about muscle, it's about physics. Thanks for watching. If you found this explanation helpful, don't forget to like and subscribe for more science insights. Stay curious.